And finally, the last concept that I want to explain in Bash scripting is a concept of functions. Now let's look at our Bash script. And even though we have these very simple, super basic examples here, our Bash script is already a couple of lines long, right? We have some conditions here with if statements and loops, etc. So imagine if you're actually writing an actual server configuration script or a monitoring script or whatever, some complex logic with your Bash script, you're going to have lots and lots of code inside, maybe hundreds of lines. And the whole thing will actually become very difficult to read and for you to have an overview of what's going on in the script. Also, if you're doing similar things on a server, you may end up with blocks of code that actually do almost the same logic, but you have to repeat them in many different places because you want to execute that task, right? Well, to solve these issues and to basically help you clean up your script a little bit, we have this concept of functions. So function is basically a way of grouping a set of logic, a set of commands, a block of code basically into a reusable component. So basically it's like a container for a block of logic, for a bunch of commands that you can give a name to, and then you can reference that whole block of code using that name, just like we did with the variable. So if you have a similar logic that you want to execute in 3 different places in your script, then you can save that code into a function, and then you can reference that function in your script. And also, as I said, function is a way to clean up your script. So basically to group things together and give them some logical names so your script is easier to read and maintain. And let's see how it works. So right here, instead of having this block of code, so basically a program that does something specific, I want to put it into a function, give it a name, and then basically decide where and how many times I want to execute this logic. So to put that into a function, we have a function keyword, and then we have the name of the function. Just like we named our variables, we need to name our functions. And let's call this a score game or score sum. And then we have the curly braces like this. And between those curly braces, we can write the logic of our function. In our case, we just want to put all of this into a function. So I'm going to copy that and paste it in here. Again, know the indentations that we use. So basically we have this outer line function definition, and then everything is inside. So everything inside the function is basically just a little bit indented. So we see that all this belongs to a function. Again, it's very much user preference for easy readability. And I'm just going to delete 10 lines here, maybe more. And there you go. Great. So we have our first function that contains that program that we wrote before. Now, let's see what happens if I save this and we execute our script. You see, nothing actually happened. We just have these 2 lines here from here. The for loop got executed, but we didn't have any parameters, so nothing got printed here. But all of these actually didn't happen, so we were not asked for a score, and this program didn't run. So what happened here is that whenever we create a function, we're just defining a function. Just like we create a variable, we just define the name, like my var, and then we assign a value to it. This doesn't print the variable value, right? It just creates a variable and that's it. We can then later actually use that variable to print it or do whatever we want with it. And it works the same way for functions. We create the function, but we have to use it if we want to actually see that function execution. And to execute a function, we just use its name like this, and that's it. And let's save this and execute. And now we have the program running. Let's quit. So again, very similar concept with variables. We create them, we define them, and then later we can use them as many times as we want. Now, as I said, functions are usually used to contain or to group similar blocks of code. Not the same, but similar. It means that one or two values may be different, but other than that, the rest of the logic is pretty much the same. So for example, we might have a function that we use to create a file. And we're going to call this createFile function. And we want to use that function for any type of file. So whenever inside the script we want to create any file, we're going to call this function. However, every time we create a file, we are going to give it a different value, right? So we want to tell the function, create a file with this specific name. And that name can actually be provided as a parameter. So just like before, we have this function definition, and after the function name, we can also provide empty brackets. And then inside the function, we have the actual logic of creating that file using touch command. And then we have the name of the file. So how can we actually read that parameter that we provide the function with? The syntax is actually the same as reading a parameter when executing a bash script itself. So using $sign and 1, we're going to grab the first parameter of that function, and we can also assign it to a variable. So let's save it into a variable called filename. And after that, we can create a file using whatever the file name is. And again, remember, this is just a function creation. It's not going to call anything, or it's not going to do anything unless we actually call the function and execute it. So I'm going to do create file, and to pass a parameter, very simple, just space and then the value of the first parameter. In our case, let's call this test.txt, and maybe in another place in our script, we're going to need the same logic of creating a file again, but with a different file name or also different file type. And let's say this is going to be myfile.yaml. Another place in the script where we want to create a shell script, and let's call it myscript.sh. And we can now test our function. Before we do that, I actually want to ignore the output right here. So these two echo commands. However, I don't want to remove them from my code because I may need them later. So a convenient way to ignore execution of a command without actually removing it is by what's called commenting it out. In Bash, whenever you start a line with a pound character, it will be ignored by the program. So it's not going to be executed as a command, it's just going to be interpreted as a comment. And that's actually pretty nice because you can give yourself some information and some notes throughout your Bash script using the comments, where you can just write normal sentences that maybe describe what a function is doing or what a block of code is doing or why you decided for the specific logic, etc. So that's what the comments are for. So we're not going to have that unneeded output. Now let's actually just echo here file with whatever file name we provide, created. Like this. And let's save. And execute. And there you go. If I do ls, I should see all three files are here. Now let's remove them again. using the rm command. Go back to the script and let's see how we can provide another parameter, because functions can have multiple parameters, just like our script can have multiple parameters. And the more configurable or more reusable you want the function to be, more parameters you would need to add. However, there is a standard guideline of best practice of how many parameters per function you should accept. So more than 5 parameters per function is too much. And the reason for that is that one of the concepts of function is to have small reusable chunks of code. So if you are basically providing lots of parameters to a function, then your function may be doing too much. So you may want to actually split it into smaller functions. However, that's one of the examples of best practices of how to write a proper script, which is readable, maintainable, etc. So with that, let's actually see the second parameter, usage. And let's say as a second parameter, we want to accept a Boolean flag that tells us whether this file that we're creating is a shell script or not. What is a Boolean or Boolean value? Boolean is basically data type that represents 2 possible values. And this is actually something common in all programming languages, including Bash. So one of the values of Boolean is true, another is false. With the if statements and while loops, we learned conditionals where we evaluate some logic and we decide whether it's true or false. And the value that it returns is actually Boolean. So again, we want to provide this function with a Boolean value, true or false, that tells the function whether the file that we're creating is a shell script or not. So the second parameter is going to be is shell script. And we read it from the second parameter. And after we create the file, if the file that we're creating is a shell script .sh, we want to add an execute permission to it. So if is shell script equals true, so true is one of the values of Boolean, and this is basically just hard coding a condition as true. We also have false, like this. So we're saying is shell script parameter value is true, then execute change mode command for user, add an execute permission on whatever the file name is. And we need to end the if statement. That's why we had the red line here. And when creating the myscript.sh file, we're going to pass in a second parameter with a value of true. And you see the syntax highlighting here because true and false are actually keywords in Bash. So Bash actually knows that we mean the Boolean value of true, which is handled differently as a special value. So basically that's our second parameter. And for those 2 files, this will be skipped because we're not providing the second parameter, so it's not true automatically. And for myscript.shell, it will try to add the execute permission. And of course, is shell script is a variable, so we have to reference it as a variable using double quotes. And let's also echo right here saying edit execute permission. Let's save and let's execute the script. And there you go. We have 3 files that were created plus edit execute permission. So now if we do ls-l, myscript.sh has an execute permission for the user. And finally, another great thing about functions is that we can actually return values as a result of function execution. So for example, if I want to return something at the end of the function. I'm just going to write return and whatever that value is. This could be the file name itself. This could be, usually when you call a function, the function processes, does something with the provided values, and then it gives you that resulting value back. A classic example of that would be a function that calculates basically or sums up two numbers and then basically just gives us the result of the execution. So let's do sum variable or total, doesn't matter, equals, and then using our expression syntax, we have the parameter 1 plus parameter 2. So adding two values together, and then we can echo it back, or as I said, we can return that value. So if we execute sum function with 2 and 10, this function execution will return the total or sum of those two values, and we can actually save the result of that execution into a variable. And one way of doing it is basically assigning the result to a variable like this, result of command execution, which we already saw a syntax for. And another interesting way of doing it is actually calling the function and then on the next line assigning the result of the previous command execution to the variable. And that is actually also a common use case and valuable thing to know. Getting the result or accessing the result of the previous command execution. And for that we have also a special variable, $? So this will give us actually the return value of this command's execution. And we're going to store it into a variable called result. And now if we echo the result like this, we can also say 2 and 10, or sum of 2 and 10 is like this. And if I execute like this, there you go. We have sum of 2 and 10 is 12. So that's the value of result that we stored right here. So that's the basics of Bash scripting, and what you just learned are the main building blocks and concepts of Bash scripting. And again, you can combine all these concepts. You can use functions in the loops, you can use conditionals to check for different cases, etc. And there are many different use cases for using Bash scripts. We can have scripts that basically run every 60 seconds or every couple of minutes that do backups, for example, that basically copy the folders and files and then back them up somewhere else. We can have scripts that monitor the network, that basically scans the network and checks that hosts are accessible or that a specific program is running, some ports are open and accessible. We can have scripts that basically configure the whole server by installing new software, creating Linux users, etc. And we can also have scripts that talk to external services, external APIs, and so on. So there is a lot you can do with Bash scripting. And as you progress in the bootcamp and as you learn new technologies and different tasks that as a DevOps engineer would do on a daily basis, you will see a lot of use cases for using Bash scripts or generally scripting. So whenever you want to automate your work of configuring servers with Bash commands, as a DevOps engineer, you can write Bash scripts. And with Bash scripts, you have a portable file that serves as a documentation of what needs to be executed in which order. And of course, it can be shared with colleagues and can be executed as many times as you want on different servers.